1 trillion. That is how many separate numbers are sitting inside some of the artificial intelligence models you already use every day. Not facts, not sentences, not words, numbers. 1 trillion tiny dials frozen into a single file. And here is the part almost everyone has completely backwards. When you picture what is inside a chatbot, you probably picture a mind, a brain in a box. Maybe a giant library it flips through to find your answer? Hold that picture, because for the next 20 minutes we are going to take it apart, piece by piece. There is no library in there. There is no little thinker. There is a file. And today, we open it. And there is one number hidden in that file that will quietly change how you read every AI headline from now on. It is the gap between how enormous these models look on paper and how little of the thing actually switches on the instant you hit enter. Keep that gap in your back pocket. We cash it in at the very end.
Hi everyone, I'm Bella, and I want to start with who this is actually for. If you have ever nodded along while someone said a model has billions of parameters and quietly thought, I have no idea what that word even means, then walk with me. This one is built for you. You picture a brain, right? A mind in a box.
A mind in a box, exactly. Last episode, we pulled apart the transformer, the wiring that lets a model weigh every word against every other word. Today we drop one level below the wiring, down to the raw material the whole thing is made of. And Bella, keep tugging on that brain-in-a-box thread, because it is the exact thread that unravels the whole myth.
Maya here, and stakes first, because this one word gets used to sell you things. Billions of parameters. It sounds like a spec sheet, like horsepower on a car. The cold fact is simpler and stranger than that. A parameter is just a number. Inside a big model, there are billions of them, sometimes a full trillion, sitting in a file. That is the entire ingredient list.
Chris here. Look at the mistake nearly everyone makes. You assume it looks your answer up in there, like a search engine flipping to the right page. It does not. There is no page to flip to.
Chris is right, and here's the cleaner way to hold it. Everything a model appears to know is not stored as facts you could look up. It is baked into those numbers. One enormous file that you could, in principle, copy onto a hard drive and carry straight out the door. A whole mind you can put in your pocket, except it is not a mind at all. And one question frames this entire episode. It is the one everyone eventually asks about these things, and Bella, you keep circling back to it. Go ahead and put it to everyone.
Honestly, I still cannot picture it. So here is the one everybody is really asking. My question, and probably yours. If there's no brain and no database in there, where does the answer actually come from?
That question is the whole game. Get the answer right, and every headline about AI suddenly clicks into place. Get it wrong, and you will be fooled by the next big number somebody waves in front of you. So let's open the file. Two episodes ago, we watched Layer 2 of the AI stack get trained. Today, we put that same layer under the microscope and read what is actually written there. The weights are the model. Billions of tuned numbers, saved to a file, holding everything the thing appears to know. That word the news anchors keep throwing around, parameter? A parameter is just one of those numbers. Only one.
See, the first time somebody told me the whole model is one file, I did not buy it. A file? Where is the magic hiding? And you know what? You are right about the file part. It really is just a file. But that only makes the real question sharper. If it is just a file, how does a file answer something it has never once seen? That is the strange part.
Let me give you the oldest picture I know for this. Back in the 1950s, you programmed a computer with a punch card, a stiff card with holes poked through it. The pattern of holes was the program. Each hole is one parameter. The full pattern of holes together is the behavior. And nobody wrote out the meaning of any single hole. A person just arranged them until the machine did the right thing. To go deeper on what is really in that file, let me bring in Yuki Sorensen, who knows these models from the file up. Yuki, are you with us?
I'm here, and can I fix the frame first? People ask what a model knows. Wrong question. A model does not store what it knows. It stores how to react. Those numbers are not facts sitting on shelves. They are reactions frozen in place.
Okay, but a punch card does one fixed job. It runs one program and only that program. A chatbot answers literally anything I throw at it. So where does your picture break?
Right where it should. Unlike a punch card, no person punched these holes. Training punched them, billions of them, nudged over and over until the pattern could handle almost any question. And look, the file part I know cold. The moment you ask what any single number means, that is a different animal. That is the black box. And I would point you to the folks who do interpretability.
Here's the ruling. A parameter is one number, meaningless on its own. A trillion of them together is the entire program, written by training and readable by absolutely no one. Picture a wall of a trillion numbers, and not a single one of them labeled. That is the model, the number wall.
One last thing, then it is back to you two, because you see how people actually use this more than I do. That whole wall is just a file. You could copy it onto a hard drive and walk out the door with it. It would be useless to read, but it would fit in your hand.
Hold on to that one, because it is where people get fooled. A file you can copy but cannot, the weights file, that is the name for it. A file you can copy but cannot read. Before this video ends, we open it and see exactly why you can't. Yuki, thank you, we have got it from here.
Quick honest ask while we are here. If this has been worth your time so far, hit like, then subscribe and ring the bell. I know everyone asks, but this one is free, and it is how a small channel like this actually grows.
Because there is nothing in there to read. That is the whole answer to why you can copy the file but never make sense of it.
Right, and it is worth slowing all the way down for, because this one idea rewires how you hear the word AI forever. When you type a question, the model does not go to a shelf, pull down a fact, and read it back to you. There is no shelf. There is a file of numbers, and your question runs through those numbers like water through a riverbed, and what pours out the other end is a fresh answer computed on the spot. The answer was never in there waiting. It gets built from scratch every single time. So let me actually draw the thing everyone gets wrong side by side. On the left, what people picture is in there. On the right, what is really on the disk.
And here's who this hits hardest. Anyone who has ever asked a chatbot something and assumed it went and looked it up somewhere, it did not. It ran your words through the numbers and made you a new sentence.
You can actually feel how big that file is. Take a trillion numbers and store each one at 2 bytes, which is the normal size. That is 2 terabytes. A file the size of a small mountain of movies, and every bit of it is just weights. No table of contents. Nothing you could ever open and skim.
So when someone asks whether the model has all the answers memorized in there somewhere.
Wait, so where's the answer physically stored? In which number?
Okay, that is the whole trap. And the honest answer flips the question. It is not stored in any one number. The real question is not where the answer lives. It is that the answer does not live anywhere at all. It gets recomputed fresh from the whole wall of numbers the instant you ask. Ask again tomorrow and it builds it again.
And that is the mint green line to keep. The answer is computed, not stored. Which, Maya, to borrow Erica's phrase, means the whole number wall is doing the work, all at once, every time.
Everything so far is the easy half, the what. The next 10 minutes is the part that actually pays off, the why it works at all. Because a wall of random numbers does nothing. So how did this one get so good?
$1.5 billion, then 175 billion, then a full trillion. Look at what they found when the files got bigger.
And it genuinely surprised the researchers. As you make these files bigger, feed them more text, and train them longer, they get better. Not randomly better. predictably better along a curve you can actually draw. Let me draw the climb with real models.
GPT-2, 1.5 billion. GPT-3, 175 billion. DeepSeek V3, 671 billion. Kimi K2, a full trillion.
And here's who this hits. Picture Priya, a 34-year-old teacher who uses a chatbot to help grade essays. Every headline tells her the newest model is trillions of parameters, and she feels like she is supposed to be impressed. So what does that number actually buy her?
Here is what it buys, and it is not what the poster promises. It buys predictability. But bigger only pays off when you also feed it far more text. And the proof of that is a model called
Bigger is just marketing. They slap a huge number on the box.
Except it is not, and here is the proof I was reaching for. In 2022, DeepMind trained a 70 billion model called Chinchilla, and it beat a 280 billion model using the same compute, because they fed the smaller one far more text. The rule they found is roughly 20 words of training for every single number in the file. Size alone is not the trick. Size balanced with data is?
Okay, that one's real.
Bella, you have had a question sitting on your face since Priya walked in. Go ahead, let's hear it.
If bigger reliably works, why doesn't someone just build the biggest model possible and win everything? What actually stops them?
Money and good texts both run out. You burn through the internet's usable words, and the compute bill goes vertical. So it's the smartest split, not the biggest number. That's the rep.
And that predictability is exactly why companies bet billions of dollars on the next model before it exists. The curve told them it would work. But hold on to the word predictable, because coming up, there is one line on this curve that refuses to behave, and it started a genuine fight among scientists. $900 million. That is how many people use the biggest of these chatbots every single week now, and almost none of them have heard the argument I am about to referee. Here is the fork, and it is a real one. Maya thinks the whole idea of AI suddenly gaining new powers is oversold, mostly a trick of how we measure. Chris thinks the jumps are real enough that if you build with these things, you had better plan for surprises. Both of them have published science on their side. Maya, make the case.
Stakes first, because this is where people get manipulated. There is a real paper, 2023, titled, Are Emergent Abilities a Mirage? And the finding is sharp. A lot of those magic moments, where a model supposedly could not do a thing and then suddenly could, are an illusion baked into the scoring. Grade it pass or fail, and it looks like a light switch flipping on. Grade it smoothly, partial credit, and the exact same models were improving gradually the whole time. No magic, just a bad ruler.
Pin it down for me, Maya. When exactly would you admit a jump was real and not just your ruler?
When it shows up on a smooth ruler too. If it is gradual under partial credit, it was never a miracle. The cold fact is, most of the famous ones melt under a better metric.
Take the other paper though, same era, Wei and his co-authors. They defined an emergent ability as one that is missing in the small models and shows up in the big ones. And here's the part that matters for anyone actually shipping this stuff. You could not predict which ability or when from the small models. Multi-digit arithmetic is the classic case, flat at random, then past a size threshold, suddenly working.
Chris, take her strongest claim head on. She says the ruler makes the miracle. Answer that directly.
Fair, and she's partly right. The drama is oversold. But smooth the ruler all you want, you still cannot tell me in advance which new thing a bigger model will be able to do. That surprise is real. And that's the number wall doing something nobody poured in, and nobody can point to the brick that did it.
Okay, picture the person who swears a model learned to multiply overnight. Woke up one morning, new superpower. I'd bet that story gets told in Ohio.
Texas, it is always Texas. Doesn't matter where. The point stands. Same model, one size up, and multi-digit addition that was hopeless suddenly worked.
It's the It's the same disagreement right there in one story. He saw a miracle. The paper saw a threshold. One pot, two labels.
So here is the complication neither of you has touched. What about a skill nobody tested for at all, that only turns up months after release when a user stumbles onto it? Is that emergence or just late discovery?
That's exactly my point, though. You can't inventory what you...
Okay, fine, you can't. Same way nobody predicts how bland Chris's chicken gets. The surprise is real.
can't test for, which is my whole point. Plan for the surprise. That's the rep.
One sentence, then. Measure smoothly, and most miracles turn into slopes. That's mine. I'm keeping the rest.
So here's my verdict, and I am naming both papers out loud so you can check me. Schaefer 2023 is right that the drama is oversold. A lot of it is the scoreboard, not the model. And Wei 2022 is right that which ability arrives when is genuinely hard to predict. So here's who each of you is right for. If you are forecasting the average, trust Maya and the smooth curve. If you are deploying the thing to real people, trust Chris and plan for the surprise. Both hold. Neither of them converts, and I would not want them to.
Right tool, right question.
Remember the gap I told you to keep in your back pocket at the very top? Here it is, and it is the strangest number in the whole file. Kimi K2 has 1 trillion parameters. But for any single word it generates, only about 32 billion of them actually switch on. The rest stay dark.
That's the trick with a name, mixture of experts. Instead of running the whole trillion for every word, the model keeps hundreds of little specialists inside, and a router wakes just a couple of them per word.
And that same trick, that is the whole reason a lab called DeepSeek shook Wall Street with a cheap, efficient model. One pot, one clever router. But that story is a whole other episode.
So here's who this hits at home. You do not need a trillion parameter monster for everything. Let me do the small math out loud. An 8 billion model at 2 bytes each, that's 16 gigabytes. Squeeze each number down to 4 bits and it's about, call it 5 gigabytes. 4.7 to be exact. Small enough to sit on a laptop, no internet, nothing leaving the room.
And here is the honest verdict, because there is a real fork for you. A small model on your own machine wins on privacy, on cost, on working offline. It loses, visibly, on the hardest reasoning and the widest knowledge where a frontier model still pulls ahead. So the answer is not which is better. It is which fits the job in front of you.
I'll be honest, I came in thinking small models were basically toys. That 5 gigabyte number changed my mind. For a lot of everyday jobs, they're genuinely enough. Genuinely.
And that's the rep to take with you. Match the model to the job. For me, it's like my morning runs in the dark. You don't need the fanciest gear to get the work done. You need the thing that actually fits your...
Which lands us right at the edge of the whole file, because here's the part that should genuinely unsettle you in a good way. That number wall, a trillion numbers with no labels, means nobody, not even the people who built it, can fully read it back and explain why it does what it does. Nobody typed those numbers in. They condensed out of training, like weather. We farmed it more than we write it. And that is the unlock, and the cost. Next episode, we point this same machine at pictures, how a file of numbers turns pure static into a photograph. And keep this black box on your list, because further into the series, we walk all the way into why the people who make these models cannot fully open their own file. Quick, before the recap. In your head, name the one number from today that stuck. Now here it is, the whole episode. A model is not a mind and not a library. It is a file of learned numbers, made better in a predictable way by scale and still unreadable by anyone.
And here is what you can actually do with that tonight. Next time a headline throws a giant parameter number at you, you will know it means the size of a file, not the size of a brain. You cannot be sold on that word anymore.
Next episode, we point this exact machine at pictures, how a file of numbers turns pure static into a photograph, and keep the black box on your list because later in this series, we walk all the way inside it.
I'm still not over Maya calling a trillion parameter model marketing and then folding in 4 words flat.
One move for tonight. Go find out how big a small model actually is. About 5 gigabytes fits on the laptop you already own.
If any of this made the machine a little less magic and a little more understandable, do me a favor and hit like and subscribe so we can keep building this course out one layer at a time. And here's the one I want in the comments. If a model is just a file of numbers, is it fair to say it knows anything at all, or is know the wrong word entirely? That is the whole picture. Be good to yourself out there, and thank you for watching. Professor Erica.